Hi, my name's Mark Falco. I'm a developer on Oracle Coherence, and I'm going to be talking about the new death detection features in Coherence 3.6. So the goals of the death detection changes in 3.6 were to reduce false positives caused by long garbage collection pauses, swapping, or under-provisioned deployment environments. Also, we wanted to reduce the death detection time. In 3.5 and earlier versions of Coherence, the minimum death detection time was 2 seconds, and the maximum death detection time, the default, was 1 minute. So there's a number of components used to do death detection. The first one I'm going to talk about is the TCP Ring component, which is used for fast process level death detection, where a process death is something like a Control C, or even something like a kill -9 on Unix, where the process doesn't have a chance to run any shutdown logic at all. So it's up to the remainder of the cluster to identify that it's gone away. So what we do with TCP Ring is all the nodes in the cluster, they form a ring. And it's actually multiple rings starting with 3.6. So the first ring circles the entire cluster, and it's a reverse ring. So you can imagine node 3 watches node 2, node 2 watches node 1, node 1 watches node 3. We also form additional rings for each group within the cluster, where a group might be cache servers, proxies, clients. These groups are just identified by the coherence role that they're put in. We compute a role by default, but you can specify your own. So there can be any number of these sub-rings within the cluster. What this means with each node can be, and of course, just a single role. So it has it's part of the one large ring circling the cluster, and then part of its own group's role ring. So at most, you're just managing 2 TCP connections in and out of the node. And death is detected by the ring breaking. So if you see your TCP connection to the next node in the ring closed, that's an indication that that node has died. So a broken ring means death. So if node 3 sees that the TCP connection to node 2 has been closed, then it will tell the rest of the cluster that node 2 has gone away. This is an active indication. Right, so in order to know that the TCP connection has been closed, we're actually going to be told by the TCP stack and the kernel of the machine, for instance, running node 2, that process was terminated and that connection was closed. So because we've been told this in an active way rather than via a timeout, there's no voting required. We know for absolute certain that process is gone. This means that the death detection time is literally the amount of time it takes for the remote kernel to tell the local kernel that the process has gone away. So it's network round trip time, and in most cases that's going to be sub-millisecond. So here's a little picture of what the TCP ring might look like in a simple cluster, where we have 3 different roles: servers, proxies, and management nodes. And you see the black ring circling the entire cluster, and then the 3 different roles have their sub-rings as well. And in some cases, the rings overlap. So you can see, for instance, in the servers up top, node 3 watching node 2, not watching node 1. That happens just as part of the standard ring that circles the cluster. But node 1 decides it needs to watch node 3 to complete that role's group ring. So the next death detection feature, and this is new to 3.6, is the IP monitor. And the purpose of the IP monitor is to detect machine level or network level related deaths. So unlike the TCP ring, here if you just power off a machine or unplug its network, there's no kernel no remote kernel to tell you that machine has gone away. So we have to fall back on a timeout-based mechanism. What we do here is, rather than monitoring the remote processes, the coherence nodes on that machine, we actually monitor the machine itself using things similar to ping. So each node in the cluster every second wakes up and chooses a random node elsewhere in the cluster a random machine elsewhere in the cluster to ping. And even if the nodes on that machine are in a GC, it's still expected that the kernel on that machine can respond to the ping in a short amount of time. If there's a series of missed pings, then we say that machine has had a ping timeout, and all nodes on that machine can be declared dead. The default configuration in 3.6 is a 15-second timeout. So I think we do a ping, each ping we wait for 2 seconds. So it's seven failed pings over a period of 15 seconds, and that machine and all nodes on it are considered dead. Here, since it's a timeout-based decision, we could, of course, be wrong, right? Somebody could have unplugged the network and plug it back in 20 seconds later. So we do allow you, in addition to changing the default timeout, you can actually veto the death decision using the new quorum policies that have come in 3.6. And here's a depiction of what IPMON might look like, where A, B, and C represent machines in the cluster, and each machine over time is pinging every other machine. And of course, it's just each machine emits a single ping packet once per second. So the actual cost on the network is incredibly small, but we do ensure that everyone will get covered. The next form of death detection is packet timeouts. And this is the original form of death detection in Coherence, but it's been revamped a bit based on the improvements in TCP Ring and IP Monitor. So the way that this works is whenever we transmit a packet in Coherence over UDP, if we don't receive an acknowledgement for that packet, we will retransmit the packet again, and the default timings is every 200 milliseconds we retransmit. If we fail to receive an acknowledgement for an extended period of time, then we will say that the remote node may have died. The default timeout in 3.6 has been increased to 5 minutes, whereas it used to be 1 minute. The reason for this increase is that this reduces the chance of death due to long GC. If you're sending a packet to a node that's in, say, for whatever reason, a 30-second GC, you can safely have that GC and act that packet well within the 5-minute window. In older versions of Coherence, because we didn't have things like IP Monitor, we wouldn't push the timeout so high because it would, if you lost the machine, you'd have to wait this full amount of time to detect the death. Here, the UDP timeout is essentially, it should never come into play. We should always detect death with either TCP Ring or IP Mon. So the UDP timeout at this level is really just a catch-all in case we have any issues detecting death at the lower levels. We also ensure that we will identify nodes that are dead via UDP by periodically issuing heartbeats. So even if two nodes have no other reason to talk to each other, Coherence will inject just a small heartbeat packet within that 5-minute interval to ensure that we eventually would detect death. When a packet times out, of course, we don't know that the other side is dead, just like IPMON. This could be just, again, a very long GC, or it could be that there's an issue with the sending node. So we ultimately will do a vote in the cluster to see whether the sender of the packet or the recipient should be kicked out. Multiple nodes participate in this vote to see who dies. It involves the sender of the packet seeks out nodes in different roles within the cluster, 2 different nodes, and then the 3 nodes vote together to decide whether the recipient that failed to acknowledge the packet or the sender that failed to receive the acknowledgement is who should be kicked out. And it's based on a variety of packet statistics. They decide which node looks healthier. And just as with IPMON, this death can be vetoed by the quorum policy, allowing you to, for instance, if you disconnect the network between 2 segments of your cluster, you could decide to go well beyond the 5 minutes without allowing any nodes to die. So in the end, what does it all mean? TCP Ring gives us what's essentially instantaneous death detection for most types of node death, which would be simply the termination of a process. Quick death detection for failed machines. It shouldn't take much more than 15 seconds to detect a machine that was powered down or unplugged from the network. And most importantly, long GCs caused by poorly tuned applications will not result in these nodes being kicked out of the cluster. Its bad GC would result in poor performance, which could then be tuned for and improved rather than resulting in an impact on the cluster. And the end result out of all of this is improved cluster stability. And here's some links that you can look at for more information on these features and other features in Coherence 3.6.